Very good morning, children. Now I want to say about Unit 5 graph theory because this is most important to your academics purpose. That is why I want to say this now. Actually, I given all notes and PDF, but I want to say because this is most important for your career and for your studies, and graph theory is most important for your course. That is why I don't want to neglect this. That is why I am making this video. Please watch this carefully and understand this carefully. Graph theory. In this, first you have to understand the graphs, then trees. What is the meaning of graph? First I want to say graph. So it is a diagrammatic or pictorial representation of vertices and edges. What is the meaning of vertex? A node or a node. So for understanding the concept of this, we have to know what is a node and what is edge. Edge is a line connecting two vertices. Node is a vertex or a point in a coordinate geometry. What is the point? That point is vertex actually. So by connecting two points, we will get an edge. That is why graph is a representation of vertices and edges connected by those vertices. That is called as graph. This is about graph definition. And if we want to write theoretically or by definition, and for mathematics we have to follow some rules and regulations to write definition. As it is, we have to by heart and we have to write a definition. So for writing that purpose of writing definition of the graph, this is the definition of graph. A graph G is equals to, here this is the thing we have to denote, and V comma E pi, and here consists of a non-empty set V. A non-empty set V called the set of nodes, a set of points, a set of vertices, and the graph. And A is said to be set of edges. E is said to be set of edges, and pi is a mapping from set of edges E to S ordered or unordered pairs. Mapping from vertices is called pi. For representing edges, a conditional statement here we can mention as a edge. So in the decision tree also, I want to say about this in data science also. Now this is the basic definition of a graph. And here two types of graphs. One is directed graph and another one is indirected graph. And in graph G, V comma E, an edge which is associated with an ordered pair V cross V called a directed graph. That means there is a direction between the two vertices, by edge. That means here directed graph is denoted by these symbols, open and closed symbols, and open and closed parenthesis is for undirected graph, unordered pairs. For undirected graph, this is the representation between the vertices, first vertex and second vertex, and a open and closed parenthesis we can use for undirected graph. That means there is no direction like this. This is undirected graph. There is no direction B to A or A to B. There is no need of mention that. Particularly 1 to 2 only. That is directed graph. 1 to 2. That is the direction if we mention in that particular graph. That is directed graph. There is no mentionality for that purpose. That means A to B or B to A. Anything we can consider or any direction we can see. That is undirected graph and this is directed graph. This is the definition of the directed and indirected graphs. And next we have to understand the concept of loop. An edge of graph which joins a node to itself. 2 to 2 only. Same vertex. Vertex to same vertex. That is loop. Okay. Here the unordered or ordered pairs are 1 comma 2. 2 comma 2 is also there. And 2 comma 3 is there. And 3 comma 1 is there, or 1 comma 3 or 3 comma 1. That is must and should, because this is directed graph and 3 comma 1 we have to write here. So in this way teachers can make mistakes to identify by students. They are testing you like that. So just understand the concept. This is directed means I have to write 3 comma 1. That you have to abstract. For a student, I am giving suggestion. Identify the mistakes made by teachers wantedly or unwantedly. Because everyone is suffering from their own issues. So because of that purpose, they may confuse or they may test you. So identify the mistakes of the students. That is the responsibility of a student. As a student, you have to identify the mistakes, ask doubts to the teacher, derive guidance or knowledge from your teacher is your responsibility. Every teacher have their own talent. You have to derive that and utilize for your purpose. and further studies, further improvement. So this is the definition of the loop. Edge of a graph which joins same node, that is called as loop. And parallel edges is also there. Parallel edge means actually between two vertices there are two lines that may be in opposite direction or may be in same direction. In case two vertices are joined by two edges in the same direction, that are called as parallel edges. And if they are opposite in direction, two edges between same vertices are opposite in direction, that is called as, here see, in the case of directed edges, the two possible edges between the pairs of nodes which are opposite in direction are considered as distinct. These are called distinct edges. And in the same direction are the undirected graph, parallel edges we can call those. For undirected graph, two edges between same vertices are called parallel edges. That you have to understand. And next definition is multigraph. A graph which contains some parallel edges is called multigraph. A graph which contains some parallel edges. Parallel edges unte dani emantarante multigraph. Next one is simple graph. If there is no more than one edge between, only single edge between two vertices, that is called as, all vertices are connected by single edges, that is called as simple graph. Weighted graph. A graph in which weights are assigned to every edge is called a weighted graph. A graph in which weights are assigned to every edge. Weights are assigned. Here V2, V3. There is a weight. There is a value assigned to that particular edge. That is called as weighted graph. Isolated node. In a graph, a node which is not adjacent to any other node is called as isolated node. And a null graph also we have to understand. In a graph, a node which is not adjacent to any other node is called as isolated node, and the graph contained only isolated nodes is called as null graph. Only isolated nodes are there and there are no adjacent node. That type of graphs are called null graphs. And in case of in degree, the number of edges which have V as their terminal node is called as in degree of V. V as terminal node. For example, so to understand this, I will draw diagrams for null graph, in degree and out degree, total degree. For understanding this purpose, I will take a paper and I will draw a graph that you can get clarity from that. Okay, my dear students, just see, you are not kids but you are my children. That is why I am using always children. And see here null graph. For showing null graph, what is the node? Isolated node I said previously. The node which is not having no adjacent vertices. So this, though no one is adjacent to any other. This is null graph. There are no edges between the nodes, that is called as null graph. There are no edges between the nodes. The only nodes are there, isolated nodes are there, which are not adjacent to any other. A is not adjacent to C, A is not adjacent to B. Just they are nodes, isolated nodes. The graph which contains only isolated nodes is called as null graph. And I said previously about degree of vertex. So degree of vertex. It is of two types, in degree, out degree and the total degree. I will say now, for example, here I am taking a graph to know the concept of degree of vertex. I am saying here and I am taking here just to see. Degree of vertex, if we want to find, I will just draw a graph. Actually, this is graph. Okay, and for example here if we have a direction like this, this is a graph. And what about the degree of vertex of A? Vertex A, degree of A. Degree of A, if we want to find out, degree of A is equals to, here 1 is out degree, in degree. This is in degree. In degree means here A is terminal node and B is actually A is initial node and B is terminal node. This is out degree. The edge which is outgoing from A is called out degree. of degree, and the edge which is coming to A is called in degree, and degree of A is equals to 2. This is total degree. Total degree. What about the degree of vertex in degree emo? In degree is 1, out degree is 1, and total degree is 2. Like that we can understand the concept of degree of vertex. And this is enough for you. This is just a basement while you can prepare because you are PG students. Next, one more thing I want to say you, the degree of vertex is the highest degree of any vertex among this. That is called as here degree of that particular graph. And here in case for considering D contains degree of vertex in degree is 1 and out degree is 2. 1 plus 2, 3. So degree of vertex is 3 for this entire graph. Degree of vertex is 3. The highest degree of any vertex is degree of vertex of that particular graph is degree of vertex for that particular graph. Degree of vertex for that particular graph. And next one is handshaking lemma. This is the most important thing you have to get from this as an application of graphs, degree of vertex concept. And what is handshaking lemma? The sum of all the degrees of vertices is equal to the double of the number of edges. So the sum of all degrees is equals to double of number of edges. 2 into number of edges. Just to see here, what about the degree of vertex of all the vertices? A is 2, B is 2, D is 3, C is 2. So likewise, totally we have 3 2s are 6 plus 3, 9. And which is double of number of edges. In case if we consider 1, 2, 3, 4, 5. In case we make it double. 5 edges are there. 5 into 2 is 10. So actually here the degree of vertex is 3 for this. In case if we consider this as here we will get degree of vertex is 3 for D. Remaining 3 are 2. So 3 2s are 6 plus 3 9. And what about the edges? If in case if we make it as double, that is 10. Actually here this is not closed graph. In case for closed graph we will get that concept. Let us see another graph. In case if I considered A, B, C. This is the graph and this is directed also, and here number of edges is equals to 3 and total of all the vertices degree is equals to how much? In case if we see, this is 6, and which is equals to 6 is equals to 2 into number of edges 6. So this is about handshaking lemma proof. In case here also we will get, but here 10 we are getting, but number of degree of vertices number is actually 9 only. Why? Because this is not a closed graph. That is why we got that contradiction here, but it is true only. Handshaking lemma is true only here. Okay children, next one is connected graph. Connected graph and bipartite graph, those things we have to understand now. And what about connected graph and disconnected graph, bipartite graph, those all I will clear now. Now I want to say about connected graph. Connected graph means there is a path between the nodes. There is a path between the nodes, that is called as a connected graph. Likewise, in case the graph is like this, there is a path existed. This is connected graph. There is a path existed between the all nodes. that is connected graph. While coming to the disconnected graph, for example, the graph is like this. This is disconnected graph. Disconnected. There is a directed or indirected, that is not a undirected or directed, that is not a matter, but there should be a path. The disconnected graph, if there is no path, that is the disconnected graph. Connected and disconnected things I cleared now. Disconnected graph. If it is bipartite graph, when it will call as bipartite graph, there is a connection between two parts of disconnected graph. There is a connection between, this is bipartite graph. So these are the things you have to understand. Cyclic graph or complete closed graph. Cyclic graph or closed graph is called as, what I take an example like this. This is cyclic graph. There is a closed connection between all the nodes. That is cyclic graph. What about the complete graph? When exactly one edge joins every two vertices. Exactly one edge. This is also called as complete graph. That may be directed or indirected. There is existed only one edge between two nodes. There is only one edge between two nodes. That is called as complete graph. These are the basic things. That is why I am saying very fastly. No need to worry about this. Next, we have to understand the concept of adjacency matrix and adjacency list. Incident matrix, that is the thing you have to get knowledge on these basic things. All you have to get knowledge. In your syllabus, this he doesn't mention, but he may ask questions, whatever it may be. Breadth first search, binary search, trees, all he may ask, but he doesn't mention anything in the syllabus. But we have to get knowledge because this is the applicational course. And also we are PG students. That is why you have to get the knowledge on this all entire things. It is not there. It is out of syllabus. Nothing is out of syllabus. Everything you have to get knowledge. You have to apply your knowledge and answer the questions, whatever you ask. So that is why I am saying now adjacency matrix. What about adjacency matrix? Just simply I am saying follow the notes. Simply I will explain. If this is a graph, what is the adjacency matrix for all the vertices? If we write ABCD like this, rows and columns like matrix form, ABCD and ABCD. In case between A to A there is a connection, we have to write 1. If there is no connection, we have to write 0. A to B we have connection, so 1. We have to write A to C, we have 1. A to D we have 0. So like that we can write a matrix form. In case B to B we have 1. B to B there is no connection, 0. B to A we have 1. So likewise we can finish the matrix. This is about adjacency matrix. Simply I am saying, fastly I am saying because you are not kids. Next one is directed graph, adjacency matrix of directed graph. In case that is a directed graph, A to A 0, A to B 1. In case B to A also 0 here, because A to B or B to A we not mentioned, but here B to A there is no connection. This is about directed graph adjacency matrix. Just understand children, for directed graph A to B will get 1 and B to A will get 1. But while taking the directed graph, in case A to B there is a connection, A to B only we have to take, B to A no connection, because this is directed graph. And next one is adjacency list. What about adjacency list? In this manner we have to write adjacency list. In case A to B there is a adjacency node means there is a edge between A to B. A to B is a connection, A to B there is a connection, and B to C there is a connection, and C to D there is a connection. So adjacency list if we want to write means here we can write the list like this. A comma B comma C comma D we can write, or else A to B, B to C, C to D we have. And next one, in case B, for B we have to write B to A we have a connection, and A to C we have, and then D. We can complete the path like this. C to A to B and B to D. D to C we can write C to A we have and A to B we have. C to A we have and A to B we have. Like that we can write adjacency list for all the vertices. This is about adjacency list. And while taking the incidence matrix, last thing is incidence matrix is between the edges and vertices. Between the edges and vertices. Edges we have to take as columns and vertices we have to take as rows. This is incidence matrix. Columns means these are columns. Edges are columns and vertices are the rows. And in case if we have incidence matrix, if we want to consider, and this is adjacency matrix. Adjacency matrix between vertices and vertices only we have take, and in the case of incident matrix, edges are the columns and vertices are the rows. That is the difference you have to understand about this. And while writing incidence matrix here, in case we have, there is just to see while writing incidence matrix for this particular graph. So in this case, all the edges we have to consider as columns and all the vertices we have to take as rows. Then while writing the matrix, in case V1 vertex is attached to edge E1, 1 we have to write. And V1 also attached to edge E2. So that is why we will get here 1. In case E3 there is a no attachment for V1. So that is why 0. E4 no attachment for V1. No attachment for V1. No. So that is why all zeros will get. While considering V2, edge E1. Edge E1 is contained V4. So there at V4 we will get 1, and at E3, V4, E3 for E3. Okay, that is why E3, V2 is also there. V2 is connected to E3 and V4 is connected to E3. That is why at that time we will get 1. And while taking E5 and V2. So here E5 is here, V2 is here. Be careful while writing incident matrix. Not like adjacency matrix, it is somewhat difficult. Not difficult, but you have to observe more while writing incident matrix. In case of incidence matrix, E1, E2, E3 are the columns and V1, V2, V3, V4, V5 are the rows we have to write. So here see which edge connected to which vertices are nodes, that we have to understand. E1, okay, E1 contains V1 and V4. So at V1 we will get 1, and at V4 we will get 1 for E1. 1, 1. Remaining all are 0. Like that we can complete the column 1. And next column 2, if we take E2. E2 contains which vertices? V1 and V5. V1 and V5. So at V1 and at V5 we will get 1 for E2. At V1 and V5 we will get 1 for E2. In that way. And next, while taking E3, if we consider, so E3 contains V4 and V2. V2 and V4. Here and here we will get 1 and 1. And next, if we take E3, in case if we take E3, V4 and V2. V4 and V2 will get 1. And in case of E4, if we take E4, V2 and V5. V2 1 and V5 1, remaining all are 0. And in case E5, if we take V5 and V3. V5 and V3. And in case E6, if we take V2 and V3, remaining all are 0. Likewise, we will get incidence matrix. And adjacency list, if we want to write for this, V1, V4 and V5, which are adjacent to V1, we can write adjacency list like this. Adjacency list. In case writing adjacency list, this is also we can follow V1. The adjacent vertices are adjacent vertices to V1 are V4 and V5, and the adjacent vertices to V2 are V4, V5 and V3. And for V3, adjacency vertices are V2 and V5, and for V4, V1 and V2, and for V5, V1, V2, V3. In this way also we can write. In this way also we can write. For adjacency list, we can follow both the methods. So this is the thing you have to understand. Follow the video clearly. Repeatedly you can revise the video and understand. That is why I am using a fast method to explain all of this, because I want to cover all the things. This is about adjacency list, adjacency matrix, and adjacent incident matrix also I said here. So no need to get confused. And next thing I want to say about subgraph. What is the definition of subgraph, that I want to say now. And what is a subgraph? Just to see subgraph. In case V of H be a set of nodes of graph H, and V of G is the set of nodes of graph G, such that V of H is the subset of V of G, and every edge of H is also edge of G. Like subgroup only, every edge of subgraph is edge of main graph. Then that is the graph, the subgraph we can call like that. For example, if we take diagram for subgraph, just to see the diagram here for subgraph, I want to see like this. For subgraph, I am writing. In case a graph is like this, this is main graph and this is subgraph. This is also a subgraph. A, B, C, D. In case we take ACD graph is subgraph of ABCD and ABD graph is subgraph of ABCD. Like that we can say every edge is also a edge of main graph. Then that particular graph is called as subgraph of the main graph. It is very clear and very easy to understand. No need to worry about this. Now I want to say about Hamiltonian path and Euler's formula. First you have to understand Euler's graph. You have to understand what is Euler's graph. First you have to understand the definition of Euler's path, Euler's circuit. A graph is a collection of vertices or nodes and edges between some of all the vertices, some or all of the vertices. That is the definition of graph. Then some or all of the vertices when there exists a path that traverses each edge exactly once. There is a path that traverses each edge exactly once such that the path begins and ends the same vertex. Begins and ends at the same vertex is called as Euler path. The path is known as Eulerian circuit and the graph is known as Eulerian graph. Just understand, no need to get confused. Each edge exactly once, and the path exists between each edge exactly once only we have to visit and end at the same vertex. Begins and end at the same vertex. These are the 2 points for Eulerian circuit you have to understand. The path traverses each edge exactly once and begins and ends at the same vertex is the Euler path definition. And what about Hamiltonian path? Here also same thing. That may be directed or indirected graph that visits each vertex exactly once is called as Hamiltonian cycle. As a cycle that visits each vertex exactly once. Here each edge exactly once. Here each vertex exactly once. This is the thing you have to understand clearly. Just I am saying fastly. Revise the video and understand the concept. I am not saying shortly. I am saying fastly. Revise the video. That is the benefit of videos. Okay. You can revise and listen the teacher's voice again and again. Here each vertex exactly once, that is Hamiltonian cycle. Here each edge exactly once and begins and ends at the same vertex is the Euler path. And what is the Euler's equation? From childhood onwards you are studying about Euler's formula. And Euler's formula is this. Euler's formula for connected planar simple graph with vertex V, E edges and R regions. R is equals to E minus V plus 2 is the formula. Edges, vertices plus 2. Edges minus number of edges minus number of vertices plus 2 is number of regions. R is number of regions. That is Euler's formula. You have to understand. I will send this pics also. Okay, Euler's formula for any planar, then E is less than or equal to 3 into V minus 2 planar graph. And also one more thing I want to say about planar graph also I will say. Planar graph means the graph in a plane. We can draw in a plane, that is planar graph. Plane means two-dimensional. In case we cannot draw that particular graph in a plane. That is called as non-planar graphs. Planar graph means we can draw that particular graph in a single plane. And Euler's formula should be followed by that particular graph. That is called as planar graph. The graph we can draw in a single plane. In a plane. Two-dimensional plane. That is called as planar graph. The graph we cannot draw in a plane. Three-dimensional diagrams. Those are called as non-planar graphs. And here let G is equals to V comma E be a connected planar graph with mod V is equals to V and mod E is equals to number of vertices and number of edges here he mentioned. And this is the graph. V is equals to 4, E is equals to 6 and R is equals to regions, number of regions in that particular graph. V minus E plus R is equals to 2. This is the Euler's formula you have to understand. Okay, this is about Euler's formula and Euler circuit I said, Hamiltonian path I said, and binary tree. Binary tree are the graphs or trees, data structures. In data structures you have to get the knowledge of binary tree. So this concept I will say in trees, and breadth first search also I will try to say in that clearly about all these things. Now I said entirely about graphs. In the next session, I will give class on trees. At that time, I will say about binary tree, binary search tree and all the things, breadth first search. And these all things I will say in trees. Now I said all about graphs. And one more thing introduced in this year is coloring of graph. What are the applications of coloring graph? That also I will say, just to see. Simply I will say Vox also we have, and follow PDF. Just basics I given in the PDF, entire syllabus covered. Just follow the PDF. And here coloring of graphs also I given notes. I'll send all those things. Just to follow all those. Basics only I can give in videos. Okay, thank you children.